to expect on the final first, so that you can start looking into that stuff. And then on Friday, if you have any specific questions or things you want me to review, I can do that. Otherwise, we'll talk about some other stuff in our game just to kind of wrap up the class and get us ready to launch for next semester. So then after we talk about the final today, then we'll go in and we'll do, our homework was to add some color commentary to the thing. So let's do that. Let's get Keynote open here. And our exam is, let's make sure, next Wednesday. So exam is a week from today at 10 a.m. Or I think it might be 10 a.m., but I'll probably be here at 10 because that's what's in my calendar. Yeah, so whatever. Let's see, here's the class here. So we'll just put a new slide here. Expect the final to be very similar to the midterm. So in terms of length, there'll be 10 questions. So 10 questions designed to take 50 minutes, that type of thing. It'll be an exam written as if you would be taking it during a normal class period. Or I'm not going to build the exam for a 2-hour final exam thing. You'll have the full 2 hours to take it. Goal being there shouldn't be any sort of time crunch issue. If you're taking a full 2 hours to take the exam, probably didn't know the stuff as well as you should. So if you felt like you could have done better on the midterm with some more time, you should have this should be comfortable for you. Then, as long as the more time wasn't more than an hour more. I need an hour more plus a group in Google. If I had all those things, I would have done better. Also remember, first opportunity was yesterday. I saw several of you there. But the senior seminar presentations are this week, so you had an opportunity of anybody who came yesterday who was there for all the presentations. We'll have 5% already added to their final exam score. Whatever you get, there's another opportunity is another 5 for the last day. So there's a total of 10% bonus you can get on the final just by coming to all the senior seminar presentations. All that information is on Slack. So you have an opportunity of 5% more tomorrow from 5 to 8 p.m. over in the pharmacy building. That will go on to whatever you get on the final exam before I compare it to your midterm exam. So if you got a 60 on the midterm and you earned a 60 on the final, you get a plus 10 on that. That was a 70. I'll replace your midterm with the 70. All right, so it benefits you double, if you will. All right, so hopefully that seems fair for everyone. I don't anticipate based on where you should be by the final exam, what you should know, the final should not be any more difficult than the midterm. But there will be programming just like there was on the midterm. And the programming, there will be a couple of easier programming questions. There will be a couple of more difficult programming questions. The more difficult programming questions, or even the easy ones, might involve objects and things like that we've done since the midterm. So the exam is cumulative in that you're responsible for everything we've done since day one of class. But as you've probably seen, programming is kind of, it just builds up, right? So, even the stuff we're doing right now involves writing if statements and writing loops and things that we talked about week 4 of the class. That makes sense? So it's not like you're like, I don't need loops anymore. That was in the midterm. It's cumulative, but I'm going to be focusing on the content we've looked at since the midterm. Okay, so having said that, let me flip through. Let's start off. Let me find where our slide is for the midterm. And I know since the midterm we've created less slides because we've done more work. So let me kind of talk about what's happened since the midterm to give you some focus on what I deem is important from that. And then let's go back and look at, here we go. This was the solution to the midterm. Okay, so since the midterm, we've really kind of looked at lists and dictionaries a lot closer, right? You know, those existed before the midterm, but not in any sort of great detail. We've worked with them quite a bit, so be familiar with both lists and dictionaries. Be able to loop through a list, be able to build a dictionary. If I ask you to find the largest value in a list, you should be able to do that. If I ask you to write a function to find the largest value in a list, that would be something that would be indicative of one of the kind of the easier programming questions. Write a loop, goes through, finds the maximum value, something like that. On the exam, I will probably specify this, but I'll say it out loud right now as well. I don't want you taking very many shortcuts. If I want you to use like a built-in function, I'll tell you you are allowed to use built-in function XYZ. So for instance, you can't just invent a function that may or may not actually exist. You know, like list find max or something like that. There may actually be a function to find the maximum value in a list that's in existence. But if I had you write that function, I want you to create a function that goes through, creates a variable for remembering the maximum value, goes through the entire list with a loop, showing me that you know how to iterate over the list, asking a question each time through, is the value I'm currently looking at bigger than the previous biggest value I found? In the end, either return or print the largest value depending on whether I asked you to return it or whether I asked you to display it. That makes sense? So I'm really testing logic. Your ability to come up with logic. Also, keep in mind, just like the midterm, I grade based on competence, not on perfection. Okay, and that's especially true when you're writing stuff by hand. It'd be great if we all had laptops in front of us and you could run it through the interpreter and try stuff, but that's just not a luxury we necessarily can guarantee to every student on a final. So unfortunately, it's just the way it is. If we had a laptop program in the department where I knew every one of you had a laptop, maybe most of you do, but it's not a guarantee, so I can't necessarily rely on it. You know, since you're writing the code by hand, there's going to be little stupid mistakes that you make that you maybe wouldn't have made had you run it through the interpreter once. And so, oh, dumb error or whatever. So when I grade your answers, I'm looking at it from a competence perspective, and I promise you that from somebody who's been programming for a long time and teaching programming for a long time, it's pretty clear when you look at an answer to a question whether this person pretty much knows what they're doing or whether this person's clueless. Does that make sense? Okay. You tend to not have a whole lot of room in the middle, okay, when you have questions. So the difference between a perfect score on an answer and, like, you know, an 8.5 out of 10 on an answer might just be a little logic bubble. Both of those are competent answers. Like you showed me, you know what Python looks like. Okay? What you get for those answers where you get a 0 or a 1 or a 2 on them is A, leave it blank. You will get a 0 if you leave it blank. Okay, but you can't just draw pictures unless it's like a really good picture and funny. Then you might get points. I'm just saying, if you're clueless on an answer, don't leave it blank. Get creative, and you know, maybe you earn a point out of that. I don't know. It depends on the mood I'm in when I'm grading it and stuff like that. But you know, just you should always write something. is what I'm saying. But you know, if you just scribble some crap down and you have a colon in there and you have like a DEF for defining something and a couple of parentheses and you expect like, oh, well, isn't that partial credit? That was part of the thing. But that's just showing incompetence, right? You know, I'm not going to give you points because a parenthesis was present, you know, and that was part of the answer, that there were parentheses in it somewhere. So I want you to show me that you pretty much know what you're doing. I'm not looking for perfection. I'm looking for competence, all right? And it'll be graded fairly from that perspective. All right, so if you're not quite sure how to write something, but you feel confident that what you're trying to write you can do, give me a little note on there. Say, I can't quite figure out how I want to write this, but this is what I want to say here. Something like that. Prove to me that you know what you're doing. Because if you had some notes sitting in front of you, you could have figured out how to write it, right? And that's okay. I mean, I recognize that. So give me as much as you can to show me that you're competent. All right, so be able to work with lists, be able to work with dictionaries. Sorting stuff, it's certainly something that is fair game. I probably would not ask you to write one of our sorts or something like that. Well, I mean, obviously merge sort will be on. Now, I might ask you about those sorts. For instance, I might ask you to show me the first 3 steps of a merge sort or something like that visually. But I wouldn't ask you to write the code to do it. So I don't want you to go memorize algorithms. You should know how merge sort works, right? Where it splits the data, keeps splitting it until it's a 1 list, and then does the merge, something like that. I might say, here's 2 partially sorted lists, so maybe I give you 2 lists, where the first one is 1, 2, the second one is, or let's say the first one is 1, 3, the second one is 2, 4. So they're both sorted in and of themselves, and I might say, show me the steps of the merge step, where you say who wins, 1 or 2, 1. Who wins, 3 or 2, 2. Who wins, 3 or 4, 3, so on and so forth. Showing me those steps by hand, that you understand what a merge sort is. I wouldn't ask you to write it, not because it's not fair, but because I don't want you to spend your time memorizing some algorithms. And I want you to show me your problem-solving skills. That's what I really care about coming out of this class. So one of the focuses I'm going to have on the final is going to really look towards the 250 class. So all of you should be registered for 250 in the fall, where we were writing Android applications. Well, we'll be doing some Java, then converting over to Android applications in Java. So it's really, this whole class has been about learning to problem solve as a programmer. Not learning Python, not memorizing, sorting or searching algorithms or stuff like that. Those are all part of the practice routines that we've done. I want you to show me that you can problem solve at kind of an adequate level, that you're ready for 250. That makes sense? So that's going to be my real goal when I write this exam, is give you lots of opportunities at, let's call it simple to medium difficulty type questions to show me where your problem solving skills are, as opposed to trying to trick you with some very difficult question. That makes sense? All right, because my job at the end of the day is to give you a grade based on how well you've mastered the material in this class that is ultimately has a goal of preparing you for the next class, right? You're not supposed to come out of this class as a professional programmer. And none of you are. Some of you feel like you're stronger than others. Some of you feel like you're not as good as you should be, but I don't expect any of you to be a great programmer yet. I expect you to be like an adequate minus programmer. Like enough to be dangerous, but kind of your own worst enemy type thing. So just understand that I know where you should be, and believe me when I say I'm not going to try to trick you on the exam. If you do get the exam, and I'll announce this when I hand it out, if you're not sure what I'm asking you, don't just make something up. Come up and ask me, and I'll try to clarify it for you. Because, sometimes I ask things in a weird way. And I don't intend to do it. So come up and ask me. I'll draw a picture or something like that. I'll announce to the class that this is what I meant by that. So take advantage of that. Don't just guess and get a bad grade on something you made a poor assumption. If it's not clear what I'm asking, tell me. All right? We talked about variable scope quite a bit, so you should understand where variables are accessible and where they're not accessible, and blah, blah, blah. I very well might not ask too many questions about that, as you saw when I introduced variable scope. Because Python's an interpreted language, scoping rules are kind of loose. That will probably be a topic I focus on a lot more next semester, where Java, is being a strongly typed language, has very, very, very defined scoping rules. It'll probably be something that would definitely have a strong presence on the midterm of next semester. Right? You should understand what variable scope means, though. That this is where a variable is accessible. All right? You can't just use a variable that you've never created or filled with something. That concept of variable scope is important, but I probably won't test you too much on, if you have a variable named name up here and you have another variable that's local here called name, and you use name here, all variables resolve to their most local definition. That's something you should understand, but I'm probably not going to really drill you on that idea on a midterm. So that's almost like a trick type thing, where if you're writing some code and you get a weird value for something through the interpreter, like, oh, I named my variable the same as something up there, and you kind of work it out. That would be kind of a quirky question maybe on a midterm. So know the concept of variable scope, but not necessarily strong examples of it. All right. This goes with the insertion sort stuff. Recursion, there might be a recursive question on there. I probably will not ask a programming question related to recursion. I might ask you to tell me what recursion is. I might give you a function that is written in recursion, give you the input, and tell you to tell me what the output is. So you should be able to read recursion. Remember, recursion is when a function calls itself, right? So if I gave you the factorial function and gave it a 5, what's 5 factorial? It's 5 times 4 factorial. What's 4 factorial? 4 times 3 factorial, so on and so forth. You should be able to read code that was written recursively, but it's more difficult to write it. All right, so I won't ask you to write a recursive function on the exam, but reading one would be fair game. Make sense? Same thing, I mentioned merge sort already. If I did anything with merge sort, I would probably do like that merge step or something like that. I wouldn't necessarily expect that though, because it's still kind of a weird question to write. I would probably rather use that question to test more problem solving skills. So I'm kind of saying fair game, but probably relatively low priority. Call it an 85% chance that merge sort won't be on the exam in any form. Doesn't mean it's not important. Doesn't mean it won't come back to haunt you in a future class, but probably won't make it on the midterm. Definitely objects. So there'll probably be a programming question where you have to create an object to represent something, like we've created dice objects that represents the number of sides. Maybe I asked you to represent a soccer player object, which maybe a soccer player has a name, a jersey number, and a position, something like that. So you need to be able to show me that you can create a class that knows how to hold a couple of fields of information related to an object you're building. So that should be a relatively easy programming question, but if we go back here and we look at our code here, I'll just go into dice specifically since that's nice and short. So if I asked you on the exam to write a class that knows how to represent a dice, where a dice holds a number of sides, you would write this right here. Class dice. Here's the constructor for the guy. He takes in a single value, that's the number of sides for the dice, and he sets his local field equal to whatever was passed in. That's creating an object that's capable of representing a dice for a number of sides. Make sense? So it should be a fairly easy type question, but make sure you understand the concept of classes. It's our opportunity to build our own objects, our own variable types, really, right? So that's the whole class thing. Understand what a constructor is. It would be fair game for me to give you a couple of classes on the exam, like here, here's a class for, player, here's a class for dice, and then maybe ask you to write a program that, write some code that uses those things. For instance, I might say, let's say I gave you the stuff we did up here. I give you dice collection and I give you dice, and I tell you to go ahead and create a dice collection for me that rolls 2d20 and then actually rolls it. So that's when you would do something like we did in player. Where's our use of dice collection? So like right here, we're creating a dice collection using the constructor for dice collection. And then we are, well, here. Modifier is a dice collection 1d4, and then we're rolling it right here. Something like that. If I give you some objects, which might not be dice and dice collection, they probably would be different than these, because I don't want you to memorize what we've already done. I want you to be able to see the definition of one or two objects and then be able to use them in problem solving. So you should be able to create an instance of those objects and then use that instance to solve a problem. Okay? Definitely the concept of self, what that means, how an object refers to itself from within itself. You should be comfortable with that in terms of the definition. I don't know if I'd give you a programming question that really relies on you being able to problem solve with that. You should be capable of it, but those are not hard problems, but they might be a little bit trickier than I want to ask on an exam. A lot of the programming questions you'll have in the exam are probably going to be like little, almost like widget kind of questions. Reverse a string, or build a string that has all the vowels removed, or remove all spaces from a string. That kind of stuff. Little kind of like practice drilly type of questions that show me your problem solving approach. That makes sense? So it's less about an individual concept, and it's more about just problem solving. So I like string manipulation stuff. I like list manipulation stuff. Probably will not ask questions that has you manipulate a dictionary, not because you shouldn't be able to. It's just they're sometimes harder to describe, something like that. So definitely be well versed in manipulating strings and manipulating lists. Adding things to a list, adding things to a string, removing things from a string, removing things from a list. Several of the drill type programming questions will involve that kind of stuff. Okay, that's the whole all variables are resolved to their most local definition. Might find its way on there in some form, but like I said, I probably won't test you specifically on variable scope. All right, so this is where we started creating some of our objects. Concept of encapsulation could find its way on there. I probably would not test this from a programming perspective on an exam, just because in order to show encapsulation, you really have to have kind of a bigger program in order for it to make sense. So probably won't make it on there in terms of a programming example, but I might ask you if I'm looking for a quick question. I might ask you, what is encapsulation and why do we need it, or something like that. Again, fair game, Java virtual machine, just the concept of that. Certainly kind of leads us into next semester, as we're going to be using the Java virtual machine in there. 50-50, whether that makes an appearance on the exam. Again, the process that all programs begin and end with main. Understand that. I probably will not have you write any code that involves you saying, the if name equals underscore name or main, that thing. That's something we introduced recently, but it's not a programming problem solving type question that I'm testing. I want you to show me you can do logic. So expect several of those little drill type programs. There'll be 10 questions on the exam. Probably 5 of them will be you having to write something. You having to write some code for something. Another couple might be you having to read code that I wrote and tell me what it does. And when I give you questions like that, you can go through and look at it line by line. That's the way you should be tracing through it. But ultimately, what I'm asking you to tell me is, as a whole, what logic does this code perform? If it finds the largest value in a list, tell me this code finds the largest value in a list. Don't go line by line and says this declares a variable called max. This creates a loop that goes from 0 to the length of the list. Those are all important things that you should be able to read, but I want you to be able to put all those together and say, this is the problem this code is solving. It finds the largest value in a list. That make sense? So expect, let's say 4 or 5 questions where you're going to have to write code yourself. Another 1 or 2 questions where I'll write some code and you have to tell me what it does. One of those might have recursion in it. 50-50 chance there for the recursion thing. So that covers 7 of the questions, right? I'm going to ask 10 questions. So now let's go back to the stuff we did before the midterm. Yeah, there's going to be at least 1 conversion question on there. Maybe even 2. Yeah, I do like conversion questions. Just 3 conversion questions? No, it won't be the whole thing. Well, there'll be a maximum of 3 conversion questions. Yeah. No, not necessarily a minimum. Well, I'll tell you here. Let's flip through this. If nothing else jumps out at me, maybe I'll just guarantee you 3 conversion questions.
So I like that.
Let's see. Let's see what we find. Because this is what I'm going to do when I make the exam. I sit in front of this and I just flip through stuff and say, oh, that's a good question. That's when I write it. And then it depends on what mood I was in. When I was, if I was angry, then the exam is worse. Question 1 through 10. Write, merge, sort 10 times differently each time. They must all work in order to earn points on exam. What's this?
Must have the most creative names for objects.
That's right. Yeah.
Otherwise you have no credit.
It does not matter what you write on this exam. Your score is already tight. Actually, just in big font, it has 0% at the top of the exam. Like, put your name on this and do whatever you want. Yeah. Score's already been recorded. I probably will not ask you trivial questions like explain to me what programming is and stuff like that. You should all know that by now. Similarly with the memory, asking questions, repetition stuff, these are all things that should be relatively second nature to you. I probably would not ask that question on the exam. Okay? All those questions about the different kinds of programming languages, interpreted versus compiled, things like that, might not find their way on there, although there could be a question that deals with maybe like the difference between interpreted languages and compiled languages, or loosely typed and strongly typed in terms of the performance of the underlying language. So the idea that interpreted loosely typed languages tend to be lower performance than compiled strongly typed languages. One of them is being run in real time at runtime. The other one is compiled prior to runtime, therefore it's faster. I would call that fair game. Let's call it 30% chance that it might find its way on there. Probably would not ask a question from here, machine level, low level, high level. You should understand what that means. More importantly for us, you should probably understand what kind of the nature of a CPU, how a CPU ultimately eats machine language, which is a very close relative to an assembly language, which is a one-to-one relationship with the CPU. I probably will not ask a question specifically about that on the final, but there might be a question that indirectly requires you to understand the nature of a CPU if I ask like a question about performance or something like that. You should know what a compiler does in case there's a question involving that. Translates from a high-level language to a low-level language. Probably would not ask about how we use assembly today. Nothing from here. Would be fair game, the difference between procedural language and an object-oriented language, since the midterm we focused on the object-oriented nature of Python by creating classes and encapsulating the details inside of those classes. That goes back to that argument about, the procedural versus the object-oriented telephone we discussed. All right, so, one of them you see a big pile of wires. The other one, all those wires are shoved into or encapsulated into the container that looks like a phone. Mm-hmm. So something from here could be fair game for one of those three questions. It would certainly be represented in the programming question, since you'll have to write at least one object. You might have to read a couple of objects. I might give you some objects and ask you to use them in your code. So you should be familiar with the classes that we wrote since the midterm. Same thing I said before, loosely typed versus strongly typed. Understand the ramifications of that in terms of performance. 30% chance that finds its way in the exam in some form. I probably would not ask you a direct question about the history of our languages. You should have a concept of that as you kind of go through the computer science program here, because you're going to see, in fact, pun intended, I guess, when you take the 450 class, which you'll take as either a junior or a senior. Let's see, you're all freshmen right now, so you'll take it as juniors, because it's not offered next year, it's offered the year after that. That's offered every other year. So you'll take it as a junior if you're a freshman right now. If you're a sophomore, you'll take it as a senior. But in the 450 class, we program in C. So it's almost like we work backwards. We start off with these languages that are, lower code, like we use Mendix at first, and I know you all love that. There won't be any Mendix stuff on the exam. But we start off with something that has you focus on the problem solving, not on the, actually maybe we should make the whole exam Mendix. Okay. So, the idea of starting off with the problem solving skills, then moving into syntax, and let's call Python a lower, less intimidating starting point for syntax-based languages. Then we jump into Java, which is still a pretty new language, specifically using Android, which is something that's, people are using today very commonly. Then you start, when you take the 470 class, you'll be writing your own programming language, so using pretty low-level stuff. When you take 325, we'll be doing assembly language programming using ARM processors, which is a one-to-one relationship with that CPU. 450, you'll be doing C programming, so it's almost like we go back in time. Because at that point, you're more prepared to deal with the scary stuff, right? Then you'll pine for merge sort in Python.
Like merge sort and assembly.
Well, that's a rough program. Yeah. But merge sort in C, that's they did write that in the 450 class. Yeah, that's a good one. Doesn't make any. By the time you're a junior or senior, you won't see merge sort through the same lens. You're like, it's not that big a deal. In fact, you might even look at it as an easy assignment. The challenge there is the pointers in C and that stuff. Huh? All right, so similarly, the idea of memory cost, if that found its way in the exam, it would be in the form of, why do some of those primitive types exist? Why do we have 4 or 5 different ways of holding integers in our strongly typed languages today? Now, since we're not using those in here, I think there's a pretty low chance that makes its way in the exam. It could find its way onto an exam or a quiz next semester, because the next semester we'll be using Java, which is a strongly typed language. So you will have those situations of choosing between byte, short, int, long for creating integer type variables. And then I might want you to address this idea of, why do I have so many choices of holding the same kind of values? Because memory used to be really expensive, and if you didn't need more than a byte of memory to hold an integer, so you were only holding values between negative 128 and positive 127, use a byte, because memory costs money. Today, that's out the window. Memory's cheap, and we don't care. Definitely conversion questions. Be able to convert between sizes. So if I say that something, for instance, if I say that you have a internet connection that is 50 megabit per second, small b, I might ask you, how many kilobytes per second could you theoretically transfer? something like that. So be able to convert between these two columns here. Understand the difference between bits and bytes. Bits are the small b's, bytes are the big B's. 1 byte is 8 bits, so it's a scalar. That make sense? So there will be one conversion question going from bits to bytes and that stuff. I really like conversion questions. Like I said, nothing from here. You should be familiar with this, but more from an overarching thing throughout your computer science degree. I won't ask you to like reproduce this on the exam or anything like that. This is question 1 on the exam. Reproduce our history of languages chart. I should actually put that on there just as I don't even know the years. I think this is around 1968. This is around 1982 maybe. This is 93, 94, probably around 98, 99. This is much more recent. It's like 2012. But yeah, these are ballparky, these things. Yeah, so all these slides that talk about that evolution of those languages, how we went from C to C++, things like that, important, but I won't be testing you over that on the final. Okay? Here's that primitive type thing where we talked about the different sizes for memory. Also, probably won't have a place on the final just because it's not something that I need you to know for the next class. It'll be, reestablished next class. Forget about the signed number thing here. That's more of a 325 concept, but you should be able to convert between binary and decimal, or binary to hexadecimal, or decimal to base 7. You should be able to convert between any base and any other base. Does that make sense? It's base 36. Base 2 to base 36, let's say. You should be comfortable moving between. So remember, we have the 2 different patterns. If you're going from decimal to some other base, you do the divide thing over and over again, recording the remainders, and then read from bottom up. If you do from a base to decimal, that's when you start at the right side, go from the ones place to the times the base place, times the base place, times the base place, so on and so forth. So if we're dealing with binary, it's the ones place times 2 is the twos place, times 2 is the fours place, times 2 is the eights place, so on and so forth. And then you sum it all up to give you the decimal value. So remember, we have the 2 different patterns depending on what you're doing. Also remember, we have those shortcuts, right? What bases do our shortcuts exist for? If we're converting from binary to what, or from what to binary, where our shortcuts exist?
Oh.
So for instance, an easy question would be for me to give you kind of a scary looking binary number, which is immediately intimidating, right? Just a whole bunch of zeros and ones, and ask you to convert that to hexadecimal. Because hexadecimal, the legal values are 0 to F, 0 to 15. You can represent that as 4 bits. So you just break that binary number into 4-bit chunks. Convert this 4 bits to its value, these 4 bits to its value, so on and so forth. Similarly, you can do the same thing if I ask you to go to octal. Octal 0 to 7 takes 3 bits to accomplish that. Okay? So be on the lookout for a shortcut. You don't have to use the shortcut. You'll get the same answer if you do it the long way. You just won't be happy about it. So if I give you some really scary looking binary number, expect that a shortcut's involved to make your life easier. That make sense? So if I give you like an 18-bit or a 20-bit binary number, I'm probably not asking you to say this is the ones place, the twos, the fours, the eights, the 16s, the 32s, the 64s, the 128s, the 256, 512, 1024, 2048, 4096. What's the next one? 16, whatever. Yeah. No, 80, whatever. 8192.
No.
So, I'm probably not asking you to do that. Okay? You could do it, and you'll get the same answer. But mine should probably put up a red flag that this is the shortcut. Okay? So, be able to do all these base conversion things. I do like the idea of going from base 10 to base 10, show your work, because that kind of shows you that those patterns are universal. I don't know if I'd ask that exactly, but one thing you definitely want to do in all those conversion questions is show me your work. Because you make one little math mistake, but I didn't see how you came up with your answer, I'm going to have trouble giving you partial credit. So show me how you got your answer. Show me all your little scratch work and stuff like that so I can see where you went wrong. And if you just made one stupid little mistake early on that made everything else off, that might be the difference between getting an 8 or a 9 out of 10 on that question and getting a 0 out of 10. Because your answer looks so foreign to me that I have no idea how you came up with this. Because you made the error so early on. That makes sense? So show your work for that stuff, for your own good. Okay. Be able to write functions. I already covered that. You're probably going to have to write for all those 4 or 5 programming questions. It's going to be write a function that does this, write a function that does this, write a function that does this. Definitely, this is circle this and put 9 stars next to it. Know the difference between me asking you to write a function that returns a value and me asking you to write a function that displays a value. Okay? Functions that return a value says, I want this function to do some logic and then return that answer to whoever called this function. And if they want to display it, they can, but they don't have to. Okay? As opposed to if I ask you to do a function that displays to the screen the maximum value in a list, then you don't have to return it. You can display it at the end of your function. Make sure you understand the difference between a function that does something and returns the answer versus a function that just is meant to do some stuff and display something. Okay? That's like automatic missed points on a question if you don't understand the difference between those two. All these history things, important, but not on the exam. Be able to pass parameters to your functions. When I say this takes 2 integers, know what that means. Okay. I think that pretty much covers it. All this other stuff is, what's a Boolean expression, things like that, things you'll need. All right, questions about the exam, the high level? So maybe start studying between now and Friday. If you want me to go over any examples on Friday, I will, and we'll finish up our little thing from our homework today. And I might cover a couple of new things if there's not questions, but I'm happy to review anything if there's something that doesn't make sense to you on Friday. Sound good? All right, I will see everybody on Friday. And don't forget about the senior seminar presentations tomorrow night.